Bienvenue à Paris. Unleashing the Power is the name of the conference. So this is what I'm going to try to talk about here over the next few minutes. But before I do, this is the 5th annual IPv6 World Congress. I've been at every single one. How many of you have been at every single one? A few. I know I see some old friends in the audience. So you guys remember, and gals, the first few congresses. Now, the keynotes I was giving, the presentation I was giving at the beginning of those conferences was really focused on the business case for IPv6. Why? Because my customers and the operators that wanted to deploy IPv6 were telling me, listen, I want to sell my management on this. And they only understand business terms. They don't understand the technical realities of what's going on the ground. So I did my best to translate that into 3, with the help of a great team, into 3 white papers, 3 presentations, and that was really what we were talking about back then. We also organized across the industry the World IPv6 Day and the World IPv6 Launch to create a network effect to get IPv6 deployed. Now, despite the fact that there's only 6% worldwide by some measurements, look at what individual operators have been able to do. In Belgium, 12 to 56% in 1 year. Comcast here, a huge network in the United States, one of the largest in the world, certainly the largest in the US residential, 2 to 30% in 1 year. So V6 launched really, really fast. We have wireless networks with more than 50% of V6 today. This is incredible, great news to me because they're the leaders that are going to get that 6% up to over 50% in the next few years. I'm not too worried about it. So if that's where we started, where are we headed? Last year, I started talking about redefining end-to-end, if you will. What does it really mean to have this IPv6 beyond just more devices? Beyond connecting the unconnected and the Internet of Things? What are we doing? We're laying a groundwork, a framework, a conduit of information. Let's talk about that today with respect to unleashing the power of IPv6. In order to talk about that, I'm going to step all the way back to our little tiny IPv4 destination address. 32 bits, 32 very valuable bits that have gotten us to where we are over the past 30 years in a global connected network. Note I don't have the source address up there. The reason I don't is because it's changing all the time. And every time it changes, it requires state in the network, and it actually holds us back to scaling and to reach into achieving what we could achieve with IP. So the source address changes all the time. This is a very valuable little set of bits. Now let's compare it to what we have with IPv6 that we've already laid the groundwork with in those operators that have IPv6 deployed and are interconnecting to make the internet. We've got 256 bits. It's not just 128. It's 256 because it's not changing. And because it's not changing from the application through the network, through services, to processes, all the way up to other applications on the other side, this is a valuable set of bits. So we've got 256 bits of opportunity here. What can we do with that? But wait, there's more. Because when we built these V6 stacks, we built them with the idea that we could have more than one address configured on the device at a time. That allows us to have multiple prefixes that again connect applications together and network topologies underneath together. But wait, there's even more. We have IPv6 segment routing, where we're using extension header features of IPv6 to define paths to the network, services, et cetera. So we're going to go through all of those. But think about this as the opportunity that we have. A globally connected set of bits that touches everything for the first time. We haven't had this since the very, very early days of IPv4 when 32 bits was enough for this kind of thing. This is the foundation we have to work with. So I'm going to go through 4 use cases of how we're applying these bits to be able to do things in new ways with new innovation. Starting with map. This is right here, right now, today. It's already being tested in certain service providers. It's available in equipment from multiple manufacturers, et cetera, et cetera. You can take a look at a demo of it. But what we start out with is a few of those bits inside, a few of those 256 bits. And we build from there and say, okay, what if I map those into v4 addresses and ports? If I can create this mapping reversible with a handful of rules that are known within that domain, now I've got something really, really powerful. I can build up an infrastructure that has IPv6 only in the center and carries not only IPv4, but port-routed IPv4, if you will. This gives us a stateless, distributed, highly scalable IPv4 CGN service. Unlike DS Lite, there's no central big piece of state that you're a stateful machine that you're tunneling up to. You can use DS Lite with this if you'd like to for special high-touch services. You could set up whatever point-to-point tunnel you want, GRE, Lisp, LW46, L2TP, if you will, mobile IP, I don't really care, right? The difference with MAP is that we're not using stateful point-to-point tunnels. We're actually using the IPv6 routing system. We're using those bits in an IPv6-centric way to create something that's scalable, stateless, and can be a foundation for IPv4 as a service. So back to 5 years ago, this was a slide that I put up way back then, and we talked about, okay, well, IPv6 is still in the laboratory back in 2010. It was kind of tough back then, right? So we're going to figure out how to do double NAT and all that kind of stuff. That was like the preserve phase. And we talked about having the prepare phase where we're going to actually get v6 deployed. So we had world days and world's launch. Ultimately, we would prosper. And back then, that prosper looked really far away. You know, there was a hope and a prayer that we would get there. And now it's actually happening with some of these IPv6-centric designs. And in fact, with something like MAP, what I'm hearing from our big 6RD customers, AT&T's got 10 million users and a terabit of traffic over 6RD. Swisscom uses it. SoftBank is using it. Of course, Free here in France is using it. What I'm hearing is, why even do dual stack? They've got single stack networks with 6RD flowing over it using border relays. They can use the same border relays with MAP and just flip it and skip a stage entirely. And that's really interesting. Nothing wrong with dual stack as the gold standard in many ways, but even the guys that have the dual stack are thinking IPv4 as a service as well. Use case number 2, multiple prefixes. Like I said, you guys know it. The v6 experts here know it. You've got temporary addresses and link locals and ULAs and globals and all this. You got, if config on your terminal window, and you get a whole pile of addresses. Well, those can be multiple prefixes as well, and I think that can be very, very powerful. It's something that we've been working on inside HomeNet, but it's applicable outside of HomeNet. So how it works is as simple as this. You have a site with a collection of stuff in it. This could be home, it could be an enterprise, small business, whatever. You got a couple of ISPs. Okay, the ISPs give you a prefix from their prefix range. And they end up, it's kind of tiny here, but both of those prefixes end up on your device. When the device sends traffic, it chooses a prefix, causing that packet to route through the particular ISP with source dest routing to the same destination. So you can kind of choose here. This is a necessity for multi-homing in an environment that doesn't have NAT and doesn't have you don't have your own provider independent prefix like a large corporation would have. So it's a necessity for home, small business as well. But also, it's an opportunity for an ISP to service differentiate as well. And that's underpinning some of the technologies that are such as prefix coloring, et cetera, which is part of the TerraStream Deutsche Telekom deployment. Do I have a glass of water there?
Sure. The glass
I'll keep moving them.
You just pick a glass from there.
Somebody will give me water. I have friends here. Use case number 3, segment routing. So let's add even more bits here. And with those bits, thank you very much, John. I get to stack up 128-bit segment routes, segment IDs. You've heard a lot about segment routing. If you go upstairs, you'll hear a lot about segment routing and MPLS. It's the same architecture, same technology, but instead of 20-bit labels, because that's what MPLS is, you've got 120-bit segment IDs because that's what IPv6 is. So same technology as applied to a different layer, as applied to a different technology. A lot of the controller type stuff that happens above can be reused in both technologies, but with IPv6, I get to go a little bit further. I can go further than the confines of the layer 2 network so that I can reach, segment routing can reach globally. I can also have 128 bits of globally unique space rather than 20 bits of locally applied space, right? Locally scoped space. But I can do the same kinds of network loose source routing kinds of things. Define your path, encode it in the source header, send it on its way, and the network knows how to send it. Same kind of stuff, very interesting in terms of traffic engineering. I can then route it through services, and then why not keep going and route it all the way to the data itself? Think about that for a minute. So you're routing traffic through a service, you route it to a web cache. Why not go beyond that and route all the way to an individually identified chunk of a video, for example, or some other piece of content? What that ends up looking like, you usually think of IP as something that you configure on your network interface, right? IP is that goes with the NIC card. With IPv6, because of the vast address space, when you think IPv6 centric, you actually route beyond the network interface. You can go straight to LBA blocks inside hard disks. You can address a single atomic chunk of data inside of a video. So what does that look like? Well, we got a demo out here that you can see. I have to ask Andre to show it to you. We set it up here in Paris, where we actually use segment routing to go through, to send a packet through, hunting for content along a cache hierarchy, if you will. Okay? So I don't know if Mike is here, if Eric is here yet from Akamai. There he is. Take a look at that. You have something to do with content distribution. But the idea is that if you can identify your content uniquely, then now you can use routing systems to route to that content at the network level. Could be interesting. Would love to talk to you about it. But it's really I'm trying to point out some of the things that you can do when you have this v6 fabric underneath. Last one, if you see Frank Brockner's today or tomorrow, he can explain it to you. Again, we've got a demo on this. It's sort of the inverse, if you will, of segment routing. With segment routing, I'm putting additional information in the packet, telling the packet where to go. IPv6 in-band OAM is a project that we worked on and we now have prototyped, where we tell you where the packet has been. Now, in the event that that's overlapping data, we're working on ways to express that without having to say it twice. But once you know where the packet's been, you can start thinking about, okay, why do I need ping and traceroute anymore? Because that's really not showing me the path that the traffic's actually going. So this lets us give you real traffic matrix, real troubleshooting, real trend analysis, and because it links all the way back up to the app, you can link applications up with interesting new application capabilities with that. So to summarize, IPv6-centric networking, platform for innovation. Today, right now, 256 bits of opportunity. You can do stuff like map that you would have had to use point-to-point tunnels for before that don't scale. But we can now do IPv4 as a service that scales incredibly. Multi-prefix IPv6, it's built into the hosts. All we got to do is link it up to the apps, and some people are already starting to do that. And we've got multiple ISPs as well as multiple services. And then with v6SR, things like in-band OEM, we can show that IPv6 is a platform for incredible innovation into the future. Little note on the demos, please go see Pierre and others that have worked on this. Here are the people that are here at this conference. Paris has sort of become a center of IPv6 innovation and governance within Cisco. We've got a new Alain Fiocco there. Senior Director of the Paris Innovation and Research Lab. This is a new thing that we've got here in Paris. Lots of researchers, a lot of engineers coming together to innovate our ass off. Thanks.
Thanks, Mark, for another great presentation. For the first time, I hear a bit of fever in your voice, so it must be exciting.